Hello students, welcome again to the another new lecture of the engineering chemistry course. As we are continuing with the unit 4, and the unit 4 we have completed the two topics cement and glass, and now we are learning about the lubricants. In the previous class we have started with the topic lubricant, in which we have discussed about the introduction part, then definition of lubricants, lubrication and tribology, functions of lubricants, classification of lubricants we have started, in which the liquid lubricants we have discussed in the detail in our previous class. In the today's class we are going to continue the topic classification of lubricants, in which we will discuss about the semi-solid lubricants and the solid lubricants. So let us start with the semi-solid lubricant, grease. Semi-solid lubricants are those which are very thick. That means the viscosity is too high for these lubricants. Generally the grease and the Vaseline is used as a semi-solid lubricants. Now question comes, what is the need of the semi-solid lubricant? Generally, when liquid lubricants are used, the bearings are to be sealed in order to avoid the loss of lubricant on account of the deforming effect of gravity. So, to avoid this sealing, such lubricants are used that resist the deforming effect of gravity. Such semi-solid lubricants are called grease or Vaseline. Now, we will focus on the grease here. What is the composition of grease? Basically, the greases are manufactured by combining three essential components. What are these three essential components? Base oil, thickeners and the additives. So basically base oil are mixed with the thickener and the required additives to form the greases. What are these base oil used for the manufacturing of the greases? The base oil comprises the largest component of the grease, representing 80 to 97% by weight in the grease. The choice of the base fluid may be mineral oil, synthetic oil, or any type of fluid that provides lubricating properties. But generally the mineral oil or the synthetic oils are preferred for the formation of the greases. Second important component is the thickeners. The thickeners may be any material in combination with the base oil will produce the solid to semi-fluid structure. So these are used to enhance the viscosity of the base oil. For example, the principal thickeners used in greases are lithium, aluminium or calcium soaps. So basically what are the thickening agent here? Soaps are the thickening agent here. And which type of soap are used in the grease? Basically the lithium or the aluminium or the calcium soaps are used as a thickening agent in the grease. Lithium soap is the most common thickener for the formation of the grease. Now third component is the additive. As in lubricating oil, additives, grease additives and the modifiers impart special properties or modify existing ones. The additives and the modifiers commonly used in lubricating greases are oxidation or rust inhibitors, polymers, extreme pressure additives or anti-wear agents. So these are some additives which are used in the greases. So on conclusory note, we can say that grease is the combination of three components: base oil plus thickener plus the additive. The main component is the base oil. To increase the viscosity of the base oil, that means to convert it in the semi-solid form, the thickeners are used. And what thickeners are used here? Generally the calcium soap, aluminium soap or the lithium soaps are used as a thickening agent, in which the lithium soap is most widely used thickening agent for the formation of the greases. Apart these two main component, some additives are also added to the greases. These additives may be the extreme pressure additive, oxidation or rust inhibitors, or the polymers are used in the greases. Now, what are the advantages of the semi-solid lubricants or the grease over the liquid oil? First, it maintains consistency in viscosity. That means if machine operates at certain high temperatures, then too the viscosity remains constant. Variation of viscosity with temperature is not too high. So viscosity consistency is there. Second important quality is these are stable towards the oxidation. Grease having good capacity of bearing high temperature and heavy load conditions. That means temperature and pressure bearing capacity is also very good for the greases. It stays well at the surface and does not contaminate the product. That means oiliness or the sticking nature of the grease is very good. These are used in the conditions where bearing need to be sealed against the entry of dust. That means it provides the sealing agent, sealing qualities also. It has resistance towards the water. So these all qualities make the grease very useful for the lubrication purpose. Now, next category of the lubricants are the solid lubricants. The solid lubricants are used under following condition. First, when operating temperature is too high and heavy load is applied, that means when pressure and temperature both are high. When contamination of lubricating oil is unacceptable, where these conditions are, then solid lubricants are used. When combustible lubricants cannot be used, because all the hydrocarbons oil generally are the combustible. Therefore, we cannot use in the industries where the fire hazard chances may possible. Most widely used solid lubricants are graphite, molybdenum disulfide, mica, Teflon and the talc. Now, two important solid lubricants we will going to discuss here. One is the graphite and second one is the molybdenum disulfide. Graphite, it acts as a boundary lubricant. What is the meaning of the boundary lubricant here? That means these forms a monolayer on the metal surface like this. So this acts as a boundary of the metallic surface. That is why these are called the boundary lubricants. These are non-inflammable, soapy to touch. It does not oxidize in air above 375 degrees centigrade. That means having the good stability. It can be used either in the form of powder as well as suspension in the oil or water. So this is the very important quality of the solid lubricant graphite here. Graphite can be used as a powder for the lubrication purpose, or it can be used as a suspension. Now, if the suspension of graphite is prepared in the oil, that means we are mixing the graphite with the oil, then this suspension is called as the oil dag. And if the graphite is mixed with water, then it is called the aqua dag. Oil dag is the graphite is dispersed in the oil. So it is called the oil dag. These are used in the internal combustion engines. So basically what we learn here, that graphite can be used in the powder form or in the suspension form, and its suspension can be prepared with water or with the oil. If the graphite suspension is prepared in the oil, then it is called the oil dag, and if graphite suspension is prepared in water, then it is called the aqua dag. So generally the oil dag is used in the internal combustion engines, while the aqua dag is used in the foodstuff industries. So basically what is aqua dag here? It is the suspension of graphite in water. it is used where a lubricant free from oil is required. That means no oiliness is there. That means no hydrocarbons are required there. So aquadag is used. Generally in the food stuff industry, we use the graphite as aquadag, and in the internal combustion engine we use the graphite as the oil dag. Now question comes that graphite is a solid substance. So how it act as a lubricant? Basically, graphite has the multiple flat plates like structure, and these different layers of carbon hexagon can slide over each other. See, look at here, these are the carbon atoms network in the hexagons. This is the graphite structure, and these hexagons layer can slide over each other. Basically, these are the hybridized bond, sp2 hybridized bonds. These one are the sp2 bond, while one pz orbital on each carbon is remaining unhybridized. So this pz orbital can overlap with the pz orbital of the next layer. So this is the flexible bond, which is formed by the overlapping of the pz orbital. So this is the weak bond and the flexible bond, and the bond length of this bond is the 3.4 angstrom, while sp2 bonds, which are the hexagon bonds, having the bond length for 1.42 angstrom. So this is the stronger bond, and this bond is the weaker bond. Due to the flexible and this weaker bond, these hexagon layers can slide over each other, and this property of graphite make it useful for the lubrication purpose. This is the property due to which the graphite can be used as a lubricant. And the graphite as a lubricant is used in the foodstuff industry, in air compressor, in railway track joints, and in the internal combustion engines. So these are the applications of the graphite as a lubricant. Now please remember that due to its layered structure, graphite can be used as a lubricant. Now coming towards the second solid lubricant, that is molybdenum disulfide. The properties of molybdenum disulfide are: it acts as a boundary lubricant, it has the sandwich structure, like in which the layer of molybdenum atoms lies between the two layers of the sulfur atoms, and due to its layered structure, different layers of molybdenum and sulfur can slide over each other. These are the flexible, so this can be used as a lubricant. The atoms in the layer are held by strong covalent bonds, and weak van der Waals forces hold the different layers. That means the bonds which are present in a single layer are the stronger bond, but the bonds which joins the different layers together are the weaker van der Waals bonds. So due to the flexibility of these weaker van der Waals forces, these layers can slide over each other, and due to this flexibility, the molybdenum disulfide can be used as a solid lubricant. It is stable up to 400 degrees centigrade, so it can be used as a lubricant at a very high temperature also. It possesses low friction coefficient, and it can be used in heavy machineries working under heavy load and the high temperature conditions. So all the solid lubricants are the boundary lubricants. That means these lubricants are form a monolayer onto the metal surface. Now let us revise what we have learned in the today's lecture. We have discussed today about the semi-solid lubricants and the solid lubricants. In the semi-solid lubricants, we have discussed about the greases, and we learned that when liquid lubricants are used, the bearing are to be sealed in order to avoid the loss of lubricant on account of the deforming effect of gravity. So to avoid this sealing, such lubricants are used that resist the deforming effect of gravity. So the greases are used as a semi-solid lubricant, and the main components of the greases are the base oil plus the thickening agent and the additive. Generally, the soaps are used as a thickening agent in the greases. Then we have learned about the solid lubricant, in which graphite and molybdenum disulfide we have discussed. Both of these solid lubricants are having the layered structure, and different layers can slide over each other. That is why both of these can be used as a lubricant. And graphite can be used in two forms. One is the powder form and second one is the suspension form. The suspension of graphite can be prepared in oil as well as in the water. If it is prepared in oil, it is called as the oil DAG. If it is prepared in water, it is called as the aqua DAG. Both can be used in different type of industries. So now, time for the learning check. Read the question on your screen. What is the role of soap in grease? Why we add soap in the grease? Think about the answer of this question. We will discuss its answer in tomorrow's live class. Till then, take good care of yourself and keep enjoy e-learning at home. Thank you.